the screen. Okay.
Okay. Okay, here we go. Thank you.
Everything okay?
Yep.
Thanks for the invitation from Lauren and you guys. I'm really glad to have the presentation. Yeah, and today I'm going to share something related to the retrieval-augmented text generation, and since because of the emergence of large language model, lots of things changed a lot during the year of 2023. So my content to present today is slightly different from that in the abstraction. Yeah, I think I sent an abstraction to Lauren about my topic today, but I delete some part like the machine translation and dialogues. Today we will just focus on the language modeling part. Okay, let's start from the presentation. Before the presentation, I want to share something interesting. Yeah, I find that actually I have some connection with your institution. Yeah, my former manager, Zheng Youzhang, who worked at your institution for a long time, and I'm really glad to join the seminar today. Yeah. And okay, let's start the main content of the topic today. Yeah, for the text generation, it's something like we try to predict given the input X, which is a sequence, we try to predict another sequence Y, given the large language model parameterized by the theta. And the traditional way has some inconvenience, like inefficiency. So we store all the knowledge in the parameters, and for those knowledge, it's also hard to be understand. The decision-making process of large language of the neural network is opaque. It's hard to understand, and we are hard to trace the model's knowledge back to the sources. And the third problem, the third problem is that we are hard to update the knowledge after training. Like the most popular way to update the model with some new knowledge is like fine-tuning the model. And until now, even the large language model is already very powerful. You can always think, you always find that the model said he cannot answer the question after a specific date because they are not training on the date after a specific time. Yeah, so that's several problems of the standard neural networks. And today we are going to introduce the retrieval-augmented text generation, which is a new paradigm. For the standard text generation, this is a metaphor to help you understand it. It's more like a closed book exam, so it's very difficult. And for the information retrieval, if we use the information retrieval, it's more like an open book exam. So everyone can check the external resources to answer your question. So that's why we love the retrieval-augmented text generation. Yeah, and there are also some advantages of the retrieval-augmented text generation. The first one is that we can learn a more compact model with less parameters. Like for the standard neural network, like for this transformer model, we store all the knowledge in the data in the model parameters. But if we use the retrieval, we can split the knowledge into the database, and we can learn a smaller neural network. Yeah. And I'm sorry. Okay. Yeah. And this way can help us to learn a more compact model. And another advantage is that by using the retrieval-augmented text generation, it's more we can get better interpretability. Like for this sequence, if we want to translate this sequence X to Y, we can find that there are lots of words that are very hard to translate. But we can first retrieve some related translation histories or translation memory. Like for the X1 and Y1, there are some related translation pairs. Yeah, we can find that there are some shared words in the X and X1. Yeah, and for the X1 Y1, we can get the alignment to know how to translate the words in the X, right? Then we can get those information to get a better translation for the Y. Yeah, and that's another advantage, that we can increase the interpretability of the model. And the third one is that we can better update the model's knowledge. Like we just said before, that if we try to update the knowledge of a large language model, we need to retrain it. But here we just need to, after the model is trained, we can update the knowledge with some external memory. Try to use the retrieval method to update. Yeah. And there are lots of successful applications of the retrieval-augmented methods, like language modeling, like the open domain dialogue generation, and so on. And today we will introducing two things. First one is what kind of retrieval models we will use in those kinds of methods, and second one is about the specific task, the retrieval-augmented large language model. Okay, let's start from the retrieval method. So the most basic method for the retrieval is like sparse vector retrieval. I think lots of people are familiar with it. This method is especially popular before like 2016. Like we use BM25 or TF-IDF to model to represent a document. And if we have a new query, we will use another TF-IDF vector to compare the similarity between the TF-IDF vector of the documents in the data store. And here is an example of the code to run the TF-IDF. This is from the GeneSim. GeneSim library is very useful library for like for compute the similarity of some sparse vector or word vector. Yeah, here they have some internal tools to compute the TF-IDF model. And here, like we can load some data and build a directionary, and then we can convert each data in each document in the data store to a BO that is the bag of words format, and then train a TF-IDF model. And then if we have some query, then we can get we can also get a vector, and then we can compare this vector with the TF-IDF vector of the data in the document in the corpus. Yeah, and another one is after the 2016, I think the dense retrieval is more and more popular. But people do not want to represent a document by sparse vectors. They use some dense representation to represent a document, like for the word vector, or some the CLS token, the hidden representation of the CLS token of the BERT model to represent a sentence. And for the dense vector retrieval, the most popular tool we use is the FAIST. For the FAIST library, first we can prepare some. This is the tutorial from the FAIST wiki. First, we can create some pseudo data to like the XB is the database and XQ is the query, and we can use the NumPy to randomly initialize some vectors, and then we can build the index. Like one of the most basic index is the index flat L2. It's this index is based on the L2 distance. And they also provide other index, like the inner products, like the index for the maximal inner product search, And also, they also provide some quantization method to build a data store on a large scale data. And after we build the index, we can search the most similar vectors using the XQ. And here, the search method will return two things. The first one is the D is the distance between the query and the retrieved data. And the I is the ID, the index of the data. So this is generally the how to use the files to retrieve something, to do the retrieval. Yeah, and recently, like from 2022, there comes. Oh, sorry, what is? Sorry for the resolution of this image is not very good. So the use the generate some researchers proposed the generative retrieval. It's like they want to train a model to learn the map from a query to a document ID. Yeah, for queries like your question, so like where is the capital of France, and where is the capital of the US, and it will generate the document ID using a model like a language model, and this document ID is generated like beam search. Yeah, so the index is stored in the model parameters, not like in this one. Is the index is stored in like a more concrete based on the index based on the L2 distance, but here the index is stored in the model parameters. Yeah, and there are some methods to represent the document ID. So here is an example. If we have a document text, how to assign it with an ID. Here, we can use some cluster-based document ID. We can cluster each part of the document, and then assign a cluster ID. This sequence is the ID of this document. There are also some content-based document ID, like the top K tokens. We just pick up the top K tokens as the ID, or we can use the BM25 scoring. We can score this document and pick up the like some top K BM some words with some top K largest words in terms of the BM25 score. And the ACID is the method proposed in this paper, in the last paper. They try to use the ChatGPT to summarize the document and use this as the ID. Like I just said, that if we have a query, the model will just to generate the document ID. Like in this one, it will just generate some phrases. It's also the natural language. Then they will use this. Then we will compare the this ID with the generated ID with some ID in the corpus, in the data store, to find the document that we want to retrieve. Yeah, this is the generative retrieval. It's quite interesting. And for the next part, we are going to introduce the Retrieval-Augmented language model. It's quite popular in recent years. And here, the most basic method in the Retrieval-Augmented language model is the KNLM, which is proposed in 2020. So, so here, the main idea of the I'm sorry. The main idea of KNLM is try to interpolate two distributions. The first one is the first distribution is the prediction distribution of the language model, like the distribution of vocabulary. And also they will use the retrieval model to get another retrieval distribution. And then they will interpolate these two distributions to get the final distribution at each time step. And here is an example. Like, let's go step by step to to know how the KN-based method works. Like for example, given a test context, the X, Obama's birthplace is what? So we want to predict this target, right? So we can first encode the X using a language model. We can get a hidden representation. And next, we also have a data store. So the upper part is the data store. So in the data store, we store lots of hidden representations that's also encoded by the same language model. And for each hidden representation, it is paired with a context CI and a target VI. Like for this representation is paired with this context CI, and the target is the next word of this context. So for the next step, we can compute the distance between the representation of the test context with all the contexts in the data store, right? We can get the distance between them, and then we can get the normalized score. Sorry, not normalized. We can get the top K score. Like Hawaii is the most similar one, and next one is Illinois. Yeah, this is the top K. We can select top K from the data store, and then we can normalize the distance to a distribution, like at this point, when we just pick up the top K targets, their score are just distance score. They are not the probability score. So here we try to normalize them to probabilities. And at the bottom, we can also use the neural network to predict a distribution of vocabulary, right? And then we can interpolate these two distributions. Like we can interpolate them using hyperparameter alpha to get the rescored distribution, to get a new distribution. Yeah, and after this, we can see that Hawaii gets the highest probability after interpolating these two distributions, and that's how the KNLM works. And there are also some methods to try to improve the KNLM, like the work from Alan. They try to use some methods to group some tokens, like for example the Hawaii or some other similar tokens. They try to group them together to get a score for those groups. Yeah, and this is the some initial methods we use the retrieval in language modeling. And after 2020, there are some new works proposed, like the law is. I think you might remember that it's one of the first work to propose the RAG. It's different from the KNLM that try to make the prediction each time at each prediction. Yeah, for the RAG method, they try to make the retrieval. The retrieval method is similar, but they try to make the retrieval just once at the beginning of the prediction. Like for example, given a question, like define the middle year. This is a query, and we can retrieve the most similar document in the data store, and we can and this is the retrieval process, and then we can get like top K documents. For each document, we can directly use their hidden representations, and while making the decision, we can base on three things. When making the prediction, we can based on the input X, the retrieved document Z. We will use this hidden representation to represent this document, and also some already generated prefix, like the like we already generate some prefix of the result y. So we can use these methods to augment our language model to retrieve some documents. And this paper focus more on the knowledge intensive tasks, because for some knowledge intensive tasks, it's hard for the neural model to answer the question. But if we give some evidence or give some like related information, then the model can better answer the question. Yeah, and that's the initial work of the RAG. And in recent years, after 2023, there began to have some work that treat retrieval as a modal action. It means that the model can learn to predict whether I need a retrieval or not. So here is sorry, this picture is not very clear. I'm not sure why. Oh, let me show the image in the original paper. I don't know why its resolution degrades. Okay, here is the method in the paper. I'm so sorry for this. Yeah, and for the original RAG method, like they would just retrieve. So given a prompt that how did U.S. states get their names, and we can retrieve top K documents like here, like these documents. Then we can combine the prompt with the retrieved documents, and then let the language model to generate the results based on the prompt and the retrieved 3 documents. But the problem is that sometimes the model may generate some contradictory content, and some information may even irrelevant to the prompt. So in this work, they proposed a method they called RAG. So like here, like we search we can check the step 1 is that given the same prompt, like here, how did U.S. states get their names? And the model start to predict that U.S. states got their names from a variety of sources, and then there is a special token retrieved. So after this special token is triggered, the model will start to do the action of the retrieval. It will also retrieve like top 3 documents, like here 1, 2, 3 documents. For each document, they will concatenate the prompt with the document and make the decision. Like for the prompt with the prompt plus the document 1, they will generate a sequence like 11 of 50 state names come from persons, and also for other retrieved documents, they will also generate a segment. But while they are generating the segments, they also need to make 2 actions to evaluate the results of the generated text. Like here, the relevant is to evaluate whether the prompt and the retrieved document is relevant, is related. If so, they can give a high score, right? And after generate this segment, they will also make a prediction about whether the generated text is in high quality, like whether this retrieved document can support this generation. If it is supported, then it's good, right? And for for the retrieve the 3 documents, we can do similar things. Like for the second one, the model predict that it's irrelevant, right? So it's not a good choice. And for the prompt 3, the retrieved document is relevant, but the generated text is only partially supported by the given prompt and given retrieved document. So in the step 3, we can rank those generated texts to get the best one, and then we can repeatedly do these things to first predict if the language model need to retrieve something, it will output this special token to start the retrieval action, and then it will evaluate the retrieve the documents and generated text, and then they will score the results to get the best results, and then continue. And that's the process of the self-reg. Yeah, and in our I'm sorry, I don't know what resolution. Yeah, and another work, it shares some similar ideas. Is that they also try to treat the retrieval as a modal action. Like here, in this work, they proposed the model proposed by them is called copy generator. Like here, given a prefix, like we try to we have an encoder like the GPT model. We can encode this prefix, right? We can get the hidden representation of this prefix. And we also have a data store for some phrases. Phrases is that because it's hard to directly copy a sentence to complete this sequence. So this method try to cut those sentences into some phrases, and to see whether there are some related phrases that we can use to complete this prefix. Okay, so for this data store, they use the start token and end token on some phrases to represent a phrase. So let's see how this model works. Given this prefix, hidden representation, and this data store, we can first retrieve whether there are some useful phrases that we can use to complete this part. And fortunately, we find something like for this phrase, like in theaters on blah 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 in the United States, after using the MIPS, we can find that it gets a very high score. So we can directly copy this phrase to complete this prefix. So generating such a long phrase only needs one step. Yeah, it's a copy action. Okay, and then we have a new prefix because it's an autoregressive model, right? We have a new prefix. Then we can get the representation of the new prefix, and we do the things again. We will check whether we can find something in the phrase data store, and fortunately, we can find something. Yeah, and we copy this phrase again to append it to the end of this part. Yeah, and for the next step, we are not lucky enough. We didn't find something, so we just like the standard neural network, we try to predict something on the output vocabulary. Yeah, and again, we didn't find something to copy in the data store. We directly predict on the output embedding. And again, and in the last step, we are fortunate enough, we find something like here. We can directly copy this long sequence to be as the end part of this sentence, of this prediction. So it's very interesting that to predict such a long sequence, we only need 1, 2, 3, 4, 5, 6 steps. It's quite different from the standard neural network, because for the standard neural network, we need to predict each step each token at each time step, right? So that's something new. There is a trend like trying to treat the retrieval as a model action to let the model to learn when to retrieve and when not. Yeah, and that's the whole content I shared today. And here are some future directions about the retrieval-augmented generation. Part is about the efficiency of the RAG. For example, if like in the standard retrieval-augmented generation method, after we retrieve some documents, we will append those documents to the input prompt, and doing this will increase the input length. As we all know that large language model is trained on a fixed window size. So if we append lots of retrieved documents, it may hurt the efficiency of the large language model, right? So this is a very important issue that when using the RAG in the real scenario. And there are already some works trying to solve this one, like to compress the document using a summarization model. Yeah. And another problem is that maybe because retrieval is a slow action. So this part, a good way is that we need to only retrieve at the necessary steps, not every steps. Yes. So we need to let the model to better know when to retrieve and when not. And there is a second issue is that there is a gap between the training and testing. Like during the inference time, we do the global retrieval. It means that given a data store, we can retrieve from the whole data store, right? But during the training time, it's hard to do the retrieval on the whole data store every time. We can just prepare some retrieval results, like the top K results. We can only train the model on a tiny fraction of the database. There is a gap between the training and testing. Yeah, so I think that's also the research problem to need to be evaluated in the future. And the last one is how to do the retrieval for multimodal database, like cross-modal retrieval. Yeah, that's the thing I want to share today. Thanks for the listening. I'm really sorry for the resolution of the images in this part. And for lots of models, I delete the detailed parts, like for this one, how the model is trained, right? I only tell the main idea of this work to avoid the to avoid that you guys are overwhelmed by the details. But if you are interested in the details of those methods, you can let me know. Yeah.
I am.
Thank you.
Thank you.
Thank you so much.
I am sure there will be questions in the room or online. Who want to start?
Okay. How to show the chat box?
I may start.
Okay.
Okay. Can we go back to the self-supervising RAG thing?
Okay. Yeah, self-RAG. Yeah.
But I think this one, yeah. Okay. Among the things you've been talking about, there was this decision whereas the retrieved document is relevant or not relevant. This is somewhere in the middle of your image.
Yeah.
How is this decided? Yeah. Is
Yeah,
relevant?
this is a very good question. Yeah. So they use the ChatGPT to make this decision. Yeah. So while preparing the training data, they will like just simulate the situation of the training scenarios, like given a prompt and like a retrieved document and some generated text, they will let the ChatGPT to give a score whether it's relevant, whether it's not relevant, and the generated text whether it's supported or not. So this is done by the ChatGPT.
Okay.
Yeah. So at the end of the paper, they show some prompts about how to do the evaluation here. The retrieval, whether it's relevant. Here is they use the ChatGPT to do the evaluation, whether it's relevant or irrelevant.
I had sort of a similar question on the retrieve tag that was added to the text. So I guess to predict retrieve as a special token in your language model, it means some text has been annotated with this retrieve tag to say, here we should run for retrieval, and how is that done? I saw in your
during
example.
the inference time is here. During the sorry, you mean so whether after the retrieval token is predicted, whether we need to do the retrieval?
I mean to predict the retrieval token, you have to have text with annotations on here. We should run for retrieval. So how was this annotation?
This is also done by the ChatGPT. Like they will annotate. Yeah, for some, I checked their examples. Like for some text, like please write a story, and for such a thing, they do not need to retrieve, right? They do not need to some external knowledge. But for some questions, like what's the best song of Bob Dylan, right? So for such questions, they need to assign a tag with that. At this moment, the model need to retrieve, and so this is the prediction results of the ChatGPT. But they think that it also agrees with humans. Like they agree that at this moment, it's better to give some retrieval documents for the language model. Yeah.
Okay, thanks.
Ulysse, I saw that you have a question. Can you ask it directly?
Yeah, I have about 2 questions on this paper. Thanks a lot for the presentation. And how do the authors deal with the additional latency costs coming with the fact that they generate in parallel a lot of ways, if I can say it like that? And secondly, how do they deal with hallucinations if there is a gap in the training dataset and the query?
I'm sorry. Do you mean that whether retrieval can solve the problems like retrieval, like solve the problems like hallucination?
Yeah.
I think that's also a question I asked the authors of this work because, like, for example, if we try to complete something, if we just copy a text from the data store, right? Whether this generated text is more, it's better. Whether it can avoid the hallucination. Yeah. But the author is also they didn't evaluate this thing on the large language model. At this moment, the experiment is only conducted on the GPT-2 size. Yeah, it's not a big model, and so the evaluation of this work is mostly focusing on the diversity and the perplexity, fluency, perplexity, or something.
Okay.
Yeah, I asked them I asked this question for this research, and they said that they are still working on large language models to see what happens whether they can solve the factual errors or something.
Okay.
Yeah.
Okay. And how do they deal with the additional latency costs on the ChatGPT side? But if we want to do it on an open source model, is it evaluated? How can we do it in a more how to say it, more speedy way? If I...
So you mean do you mean is this question for this paper or
Yes,
this one?
no, self-reg.
For this one?
No,
For the
self-reg.
self-reg?
Yeah.
Okay. Yeah. So I'm not sure, yeah, because this when to retrieve and whether the two things are relevant is really hard to judge. I think it's even for humans, right? And I'm not sure whether there are some cheap alternatives to do this.
Okay.
Yeah. So, but they label this data using the ChatGPT. I think this is a very good work. They spend a lot of effort on this.
Okay.
Yeah.
Okay. Thanks a lot.
Thank you.
Yeah, thank you for the presentation. I have a question regarding cases where you maybe don't have really an answer or where the prediction should not be done. If you consider RAG as a way to query a document base, those documents might not treat some information. So, for example, if you have documents about the financial lows or whatever, and then you ask the questions about fruits, it should not answer, or at least there is no good answer to that question because in the document there is no information about that. How do you deal with those cases?
Yeah, the for the RAG, they just they just I think they have some mechanisms to handle this situation. Like they can predict the irrelevant token to score the relevance between the prompt and the retrieved document. And for other methods, like for the copy generator, I think they mostly done by some because the model learned some contextual based embedding. Like you said, if the prompt and the documents are too irrelevant, so it's really hard to get the documents to be retrieved. And if the worst thing happens, I can think like if they cannot find something related, they will just learn to use the token embedding. So I think at least in those models, they have some mechanisms to handle those things, to handle the bad cases, some extreme situations. Yeah.
And those mechanisms are always applied afterwards, after the context has been retrieved, right?
Yeah, that's right.
An a priori procedure.
For this one, for the initial for this one, the retrieval happens at the beginning, so maybe it's difficult to solve the situation like you said. But for those, for the self-reg and the copy generator, they will rescore the retrieved documents compared with other information sources. Yeah.
Okay, thank you.
Yeah, thank you.
Are there any other questions in the room? Or online?
No, I have some. Thank you for your presentation. I have a small question on copy generator. So once the answer is provided by the RAG, is there any way to know which part of the answer is copied by from sources and which one was generated by token embedding? Was generated.
You mean I'm sorry. Your question is about whether how to know whether ways to be copied is better than the token embedding?
No, my question is, once you get the final answer, given your prompt by this method, is there any way to know which part of the answer was copied from text and which one was generated?
Yeah, it's okay. Yeah, we can do this. Like we here we have some colors that since copy is a concrete action. So after we copy text from the database, we can know the boundary of it. So we can, after generation, we can know whether a snip of this generation is copied or is from the token, from the step-by-step token prediction. Yeah. Is this
Yes.
answer your question?
Yeah,
Okay, thank you.
Just last question, is there any benchmark, existing benchmark on which all these methods can be evaluated and compared?
Yeah, that's a good question. Like in this work, they evaluate some popular language modeling and text generation benchmarks like the Wikitext 103. And for this method, because for the self-reg, because they need the external knowledge to make the decision. So they mostly evaluate on some QA tasks. Yeah, so for such tasks, they need the external knowledge to retrieve some knowledge, to retrieve some useful documents to answer the question. Yeah.
I can add a question on the copy generator. Like if your span selection mechanism to select the number of spans in the database to copy provides several answers, how do you disambiguate or choose between the different spans that could be copied? There's a scoring function, maybe some more?
This is a good question. So I would say that so to determine the span, they actually do some annotation on the training data. Like they first for training data, given a sentence, they will first retrieve some related documents and try to using the maximization based matching to annotate the shared spans appearing in the retrieved documents and appearing in the query documents. So that's their method. They use this they use this for training, and as you said, the disambiguation, that's also a question I asked those also didn't do specific modeling for this part, or they didn't evaluate this the disambiguity ability of this model.
Okay, thank you.
Okay.
We'll read the details.
Okay.
That's nice.
So do we have other questions around? Well, in this case, thank you very much again for your talk, which was dense and rich. And now we have food for thought. Thank you very much, and talk to you later. Thank you.
Thank you.
Thanks a lot.
Again, enjoy the food.
Okay.
Have a nice day.
And my apologies for the resolution of this.
That's
Of
okay.
this
Okay.
PowerPoint. I'm so sorry.
That's okay.
Okay.
Thank you. Goodbye.
See you guys. Bye bye.
Thank you very
Thanks.
much.
Bye.